And Salvatore, I hope your brain hurt at the end of this. Last year, for those of you who were, as Salvatore talked about, I talked a lot about Sentinel, and I found Sentinel and different ways to use it. If you're on Stack Overflow and you see any Sentinel questions, you've probably seen me respond to it. However, this year I'm not going to talk about Sentinel a whole lot. I have a few items about Sentinel, but the rest is about Redis. And what I'm doing is I'm approaching Redis from the operational standpoint, from some very different operational use cases. So when we talk about use cases in Redis, we're usually talking about from a developer standpoint, from data standpoint. You know, I have some data, how do I want to store it? But I'm kind of working with this idea of operational use cases. And some really good examples of that, Redis cluster is an operational use case. Sentinel with master-slave pod replication, that's another operational use case. So there's been some that have been developing over the last year or so that I really want to focus in on. And more we see Redis on the cloud. AWS has Elastic Cache, we have Redis Labs, there's Object Rocket, there's Redis to Go, there's a whole list of this. And if you look at anything in, say, the Docker world, whenever they say, here's how you make a small platform as a service, what's the example that's always used? It's Redis. So Redis is kind of, if you think about it, being perceived a bit as the cloud database, the database that you use in the cloud, because it's so easy, it's so simple. And that really resonates with the container concept and a lot of stuff we do on the cloud. So I kind of look a lot at that, and that's what we mostly talking about. What I'm going to do here, I have a lot that I could talk about. I could probably eclipse Salvatore's time if you wanted me to. So what I want to do is I kind of want to go through and hit the high level. And if you guys want to get into more details, we can certainly do that. I'm going to propose several changes to Redis today, and or
tomorrow night.
Yeah, tomorrow night, or anytime today. So I'd really like to get some feedback on these so when I submit the RCP that it's really got a lot of the stuff covered in various RCPs. So the first piece I want to talk about is configuring Redis. Now, the thing I love about Redis is that I can configure almost everything through the API that I can use to the config file. And I can also do that at the command line. A lot of people may not realize this. But if you want to, say you just want to fire up quick Redis to test some commands, you don't want to worry about a dump RDB sitting there. You can say --save space .. and you will turn off persistence right on the command line. Kind of thing a lot of people don't realize is there, but it can be really, really useful. So that type of stuff I want to go into. Some things I want to have an instance ID. Kind of like Sentinel now has a unique persistent ID. Every Redis instance, I think, should have one. For many of the same reasons. Once you start moving Redis instances around on a cloud, you take the idea that Redis doesn't necessarily live on the exact same host all the time, but you want that specific data to be able to move around and be somewhat portable. That being able to identify that specific instance becomes quite useful. It enables you to do a lot of good things. Announce information. So for those of us that play running Sentinel behind Docker, not so much fun a year ago. Now we have Sentinel announce IP, Sentinel announce port. The idea there is when you run something behind Docker, for those of you who haven't played a lot with it, it basically does port translation. And Docker by default is a NATed setup, so off that host you can't directly connect to the IP that Sentinel thinks it's running on. So Sentinel announce IP and Sentinel announce port do is they allow you to tell send your hello message, use this information so other people, the other Sentinels can actually talk to you. And what we don't necessarily realize is when you run Redis behind Docker or VirtualBox or any other solution that works this way, is you have the same problem. Only there you have it with master-slave. And you'll see it if you use your slave to query information about the master or vice versa. The IP information, the port information is incorrect. And then you also see that in Sentinel because that information is not what Redis reports to Sentinel because it doesn't know it's NATed or it's port translation. It doesn't know those things. So I've started playing with this about 3 or 4 months ago, and I actually came up with some proof of concept code for a process to actually do that. The idea is we take the exact same principle. We have an announce IP and announce port, just like we do for Sentinel, just drop Sentinel off. The difference is you have to be able to configure this runtime, because you don't necessarily know. In fact, you almost never know what the IP and port is going to be. Docker will pick an IP from its pool, it will pick a port from its pool, and assigns them. So you can't set that by the command line, you can't set that in a configuration file. So what I did is I added a command to add that. I just put it in the config, say, add this in there, and it worked. So I could do that, I could do slave of, and the announce IP and announce port would be what I had dynamically mapped. So it was really simple. However, there's a catch. Once you issue that slave of, you can't change it, because it's already sent it. Now Redis could send that again, and that's something that I want to explore when we, if everybody wants to go into the details of it. And then there's environmental config. Anybody here familiar with 12-factor app? So you guys know what I'm talking about already. Those of you that don't, 12-factor app is it has 12 principles of how you should, architect your software or design software, whichever. And one of those is take your configuration from the environment. Now, we have it on the command line, and that's fine, but environment variables allow us to go a little bit further. One of the great ways you can use this is with Docker again. Again, buzzword bingo, you can hear Docker a lot today, for me anyway. With Docker, every time your config is already going to be there. So you have to override that config through the Sentinel or through the Redis API, which you can do. Config, but then that config is only for that instance. What if you want to have just one variable different? Well, you could pass additional parameters to it, but then if you've ever seen a Docker file that launches a binary with 10 or 12 different parameters, you know how ugly that can get. However, the best thing about Docker with this is you can pass environment variables to it. So we would say, for example, Redis underscore save. And you could just set the environment variable when you run the container, not when you create it, and that's a key difference. In Docker, when you run the container versus create it, you can change environment variables. You can't change command line switches. So what this does to more easily integrate with Docker and the upcoming Rocket, I know they're going to be doing the same capabilities there. So that makes Redis easier to use there. And if you're doing things where you're deploying, let's say you've got a 24 and you want to use all those cores, set things in your environment script and your startup script, and off you go. So it also becomes simpler and easier to use outside of that. And this brings me to configuration state. Now, I mentioned a moment ago the idea of sending Redis a command to say, this is your announce IP, this is your announce port. The idea that you launch your Docker container, it tells you the IP and port, and then you tell Redis. You have a problem once you do slave of. So I wrestled with this for a little while, and eventually I came up with an idea, and I think something you mentioned, Salvatore, at the end there, this could actually help with, and that's the idea of the protected restart. The idea I came up with is, when Redis starts, we should be able to start it to where it doesn't manage data yet. So imagine a window, say 5 seconds. You say, all right, I want you to start up. Once you start it up, you've loaded the RDB, perhaps. Maybe you've loaded AOF, details to be determined, but you're not going to modify data, you're not going to serve data. Redis is just going to sit there and say, okay, for 5 seconds, I'm going to wait for configuration commands. Now you put those two together, and now you can set that up. You can say, start the Redis container, get the IP, get the port, set them over the API, and then with another command, like ready state or something like that, just kind of the name, the rough names working with it. But with the command, you say, all right, I'm done configuring you, go off and start. So that gives you the ability to bring up Redis somewhat configured, but then able to apply custom configuration templates. And if you're deploying a lot of Redises across multiple hosts, multiple data centers, this gives you a nice template you can easily use to do that. And so that's the configuration state. And I think, Salvatore, that might be useful with the idea of protected restarts. If it's not serving data, if it's not managing data, where we place loading data in there could be a factor maybe in helping solve that problem. And the last configuration item is configuration replication. If you're using master-slave setup and you go to your master and you say, I want to change your zip list settings for the hash memory values, your slaves don't know this. That means if you want to do this type of stuff, you have to ideally interrogate your master, determine where the slaves are, and then go tell the slaves as well. Now, as a coder, you sit there and go, well, that's not hard. I can tell you as an operations guy, when you've got 100 of these, you've got 500 of these, when you've got 1,000 of these, and I know people that are running thousands of these, that sucks. So the idea here is that some configuration set to the API should be automatically transferred to one or more slaves. And there's a few things we can play with and tweak here. One is the idea of having a variable that says all slaves get this list of directives. So you could say, well, if it's set one of these memory settings, every slave gets this replicated to it. So then when you do a config set, hash zip max, hash zip list, entries, something like that, whichever one it is, then that one gets replicated. But maybe you don't want all of them. So save. What if you don't want to run persistence on the master, but you do want to run it on the slaves? Or maybe you have some slaves that don't. The ideas I'm working with here is being able to specify and everybody gets this list, and either an exclusion list, so this slave doesn't get these, or an inclusion. So this slave only gets these. And there's different ways we could do that. I think they all work. And that can really help out when you're starting to manage large amounts of Redis instances, is being able to replicate that out. The configuration aspect of it. Not a lot of not really huge things to change there, but some semi-minor things I think could really help out the operations folks running Redis. And on that, there's actually something else, and that's instance metadata. Now, since we have this a little bit with Sentinel, we have persistent run ID, we have run IDs on all Redis instances, so that's some metadata. The idea here is to take that a little bit further, and again, have the persistent name, as I like to call it, or the ID of that Redis instance. And on that particular aspect, that should be something I could set via the API. And that kind of goes back to a little bit of deploying them dynamically, being able to set that without having to set it in the config file. It should be able to be persisted there, perhaps. This metadata should be simple key value, no sets, no sorted sets, none of that, just basic key value. Things like which availability zone am I in? Which region am I in? That's the kind of information. Think of almost like tagging the instance. Once you have this, you have the ability to then do a full discovery of your entire Redis environment, which is really amazing for auditing purposes. Again, once you have 100 of these little things that you do that take 2 seconds now take a long time, and now you also wind up having a team to get this information to. Now, yes, you could store that in a database somewhere, but it's not integrated, it's not dynamic, it's not real time, and that's one of the things I love about Redis, is I can go to the info, I can go to the config, I can get this information dynamically, and that's the idea here, is all be there and keeps Redis being the discoverable database. I have not seen any other database, maybe there's somewhere I haven't seen yet, that is as Red Skull, which is a Sentinel managed API and web service. It discovers everything through the Sentinel configuration as a Sentinel instance directly. Everything you see in that is completely discovered. Being able to put metadata in there makes that even easier to do. And for this, I'm kind of thinking of a meta command. Take config, change it to meta, and now put in a different namespace. I mean, when I set metadata, I don't want that to be listed in keys. It needs to be completely separate. Anybody here use Elasticache yet? Have you done a keys on a brand new instance and found that there are keys in there? That's because it's all conjecture on my part, but there is a replication timestamp being set in there. And since Amazon lets you do multi-availability zone, I believe, again, pure conjecture on my part, that they're doing that to manage multi-availability zone replication.
And check it in monitor.
Yeah. And that is an example, that's a real world example of where this would be useful. Is rather than putting it there where iterating over keys, now I did test, you flush it, it will come back. They are periodically set. Don't worry, you won't kill it. At least I couldn't. But the idea of having it separate is important.
So, can you repeat that?
Pardon?
Can you repeat the idea?
So the idea is that all this metadata is separate from what I call your user data.
Okay.
So like in your case, customers wouldn't see this information unless you gave them access to the meta command or whatever it becomes named. But meta get, meta set, and yes, even potentially sync. Maybe you want certain things to sync. Great example of that, if you use Red Skull or you're like me, you wrote it, the thing you get into is when you look at the nodes don't know what pod they're in. For those who don't know, there's Res cluster, and then there's what people have been calling clusters for a couple of years, but I call them pod. It's a master-slave setup. I just don't like the confusion of saying cluster meaning two different things. So what I call a pod is the name that you give Sentinel for that master. Okay, let's call it web cache in this example. The nodes don't know that they're part of the web cache setup. That should be something that we could set. That'd be another example of where this would be useful. Because then you could actually set that, and maybe Sentinel could do it. That's something that Sentinel can say, oh, I have discovered you as a slave, you are part of this pod. You are, this service, whatever you want to call that thing. And then that can be set there, and then, or perhaps you set that in the master and it gets synchronized.
This, the number of key values that you can set per instance will be so limited to just 100 or something like that?
Absolutely.
So we can store it even in the configuration file in order to persist it, stuff like that.
Yep.
Yeah, this was, this also automatically provides instance names. That's another feature that people want.
Mm-hmm.
The ability to name each instance with a specific name.
Right. And actually having my notes when I was working this out, and perhaps this is where we put the ID for that particular instance.
Exactly.
It doesn't have to be a config variable, but it should be something that, that you could persist, and sometimes you might want to sync. So that's the metadata piece of this. And that's something I think, looking at it from an operational standpoint, again, one or two of these, it's not going to make a big deal to you. A lot of them, it really does start to become a really big benefit to use. And I actually do see people doing this with just using key values. And some of their experiences is why I determined it has to be in a separate namespace. Because as many times as we can say to the community, don't use keys in your it still happens. A lot, It actually showed up at the Redis conference earlier this year when I did a command analysis across Redis to go and out to Rocket Redis and what, the commands, it actually showed up in there. It's done that often, and I still see that on Stack Overflow every week. There's somebody saying, oh, just use keys for that. Other things, I see people doing their own replication. They use DB size, so this could throw that off as well if it was in that namespace. So, separate space for it where it doesn't show up in users. So, yes, I do a lot of Sentinel. I still do have some things to talk about on it. The idea of the metadata could apply equally to Sentinel. It could also be very useful there. For me personally, the way Red Skull is working and moving in the direction of being able to deploy Sentinel as a cloud of Sentinel instances, and then when you add it, rather than talk to Sentinel, you talk to Red Skull, you say, I need a quorum of 4, and it will go pick the 4 least used Sentinels. So it gives you that scalability of Sentinel. And metadata for that would be really useful, to be able to identify them directly and name them. Right now I have to do IP port And again, if you're moving things around, IP port doesn't help. And you may not know the right IP port because of that, if you're running behind Docker, for example. Sync. Maybe Sentinel should do some syncing of the configuration values for Redis. Maybe. Maybe it should give you the ability to synchronize within Sentinel. So for example, there's a Sentinel option called parallel syncs. Number of parallel syncs Sentinel will use for the replication. But again, if you set that on one Sentinel, you have to go set it on every Sentinel in the list. And that's something that iteration over every single Sentinel you own gets really tedious and overly complex. So perhaps something that we could have in Sentinel is the ability to set a value for a pod and then have that pushed to the other Sentinels. It already knows about the other Sentinels. Why not do it for us? Now this one, somebody asked me during the break how many, if I had a lot of issues to talk about Sentinel again this year. I don't. I only have a couple. One of them is a particularly close to my heart one. It's one that you will see me on the list saying, don't do this. Because people go on Stack Overflow, they go on the Redis list, and they say, Doctor, I put Sentinel on my Redis nodes. And it hurts. What I'm seeing a lot of lately is they do this, and they're doing the smart thing. They're testing. If any of you are out there doing the testing, you're doing it right. And they kill the node. They kill the host machine. That's a very valid use case a lot of people don't think about. They do that, and then Sentinel can't fail over. They have 3 Sentinels. They have 3 nodes. They have 3 Redises, 1 master, 2 slaves. They kill 1 Sentinel. And with Quorum of 2, it still can't fail over. I don't know why. I have some theories. They're just really rough guesses. But ultimately, from an operational standpoint, why isn't important? The fact that it does it is important. So that means we as a community need to get better, and perhaps it's something we need to change the Sentinel documentation on to say, don't do that.
So you have 3 different virtual machines, and each run 1 Redis instance and 1 Sentinel.
Yes?
And the problem is that if the Sentinel instance is killed,
If you kill the master host, so that VM goes completely down, the Sentinel and the Redis master.
yeah, the failover should happen the other side.
It should happen.
Doesn't happen.
Doesn't always happen. I've had in the last...
Very strange.
I suspect, now, I haven't quite worked out all the, I'm trying to get it to where I can replicate it. And on the flight over here, I was thinking about it, and I suspect that it might be if a failover has already happened. So if you start one up blank, and then you do that, I suspect it will often work. But if you've done a failover for that pod already, then I think it fails, and I think it fails if the master was also the leader in Sentinel, if that host. So you're killing the master and the previous leader, I suspect. I haven't confirmed it.
It's, as usual, it's not just a delay, because it's possible that in the setup you say there is a delay.
Yes.
But basically, in this setup, there is nothing wrong about the topology itself. There must be some bug that happens in other scenarios, because there is nothing special about running 3 Sentinels together with the masters. And also, it's one of the use cases that's tested by the unit tests.
Yeah, and like I say, as I'm trying to get a repeatable scenario. The last 3 weeks, I'm on people saying, "Hey, Sentinel doesn't work." I'm like, it does, and every time I said, "Go do it, put them on different nodes," and they do that, and it works. So, operationally, it's arguable that you shouldn't put your monitoring solution on the nodes they're monitoring. But yes, it should work in the code, but it's not always working. And it's only in that specific case. And I'm trying to narrow it down, but it is something that Yeah, it's a Sentinel issue, and it's me, so I got to talk about it.
It's possible that this was due to recent bugs fixed, because there are certain bug fixes in the latest 1 or 2 months that could be affect this as a side effect of some different bugs like that actually.
Yeah.
Or something like that. Because issue are absolutely one. There's a few one needed is selected. Well, the new versions of Sentinel, when they cannot fail over, do something in the past. At some point, they log why they cannot fail over. So now it should be simpler to identify. Because if a failover is not in the past, it just was like that. And now it writes, I am not able to fail over if I'm detecting master is down. Follow the
Excellent. Excellent. So yeah, that's the big one. I've got another one, and I tried to capture this semi-complicated scenario into a bullet point, and that's what I come up with. Sentinel remove data lag. So here's the scenario. You're doing testing across multiple hosts, multiple VMs, and you're testing failover. And you're doing this in a repeated fashion. So you're doing like hundreds of these. A great example is the bug you talked, the software you talked about. Some number of pods on a given constellation cluster, and you kill half of them. At some point, it starts taking a long time for each one to get failed over. So imagine that type of testing where you're trying to do this as quickly as possible. If you remove a pod, if you remove a master from Sentinel, and of course you have to go across all 3 in the case of a 2-party, you remove them, and then you re-add using the same name. If you do that quickly enough, the old configuration comes back. And that's even if in between the remove and the re-add, you have a do you exist call. You're asking Sentinel masters for this pod name. And it says, nope, I don't know about that guy. But then if you add it back quick enough, it's actually still there. And I was able to track this through the logs. And I think it only happens if you have had an epoch change on that master at some point. Because the entries I see in the log is, oh, well, this other Sentinel has a newer configuration than me, and it restores the old configuration. Now, I briefly looked at the code, and I suspect it's just a matter of basically saying, yes, I'll go delete that for you, and then removing the entry, but it still being there, but not accessible until you put the same name in there. Put a different name, it doesn't happen. Put the same name in, and so that's where I suspect the issue is.
It's possible that you remove the instance, but still in the output buffer of one Sentinel, there is a message about this instance name that is still pending in the socket. So when you react, this message reaches the Sentinel because the name matches, and it's sends it as a newer configuration.
Yeah. And so, I've seen that there. I do know of it happening a few times in production. So it's definitely, my first thought was this is really not about use case. You shouldn't be doing that. You shouldn't be removing a master and then adding a different one with the same name, but reality is sometimes it does happen. And if you're talking about, like, if you're trying to do a dynamic web cache, I could easily see that happening. You're doing auto scaling, things coming up and down, that could happen. So only 2 issues this year for Sentinel for me. I still want the goodbye message. When you say Sentinel remove this guy, I still think that Sentinel should tell the other Sentinels it knows about, hey, I am leaving. Don't count me anymore. Take me out of your entries. Rather than having to go to every Sentinel and remove it directly. Kind of sense a theme here on that one. And the slave remove, still want to be able to say, hey, Sentinel, get this slave out of your list for this pod. And that actually is, I think, why some people do the remove and re-add. is they don't want to do a reset, so they remove it and then they re-add it. And that's where we start to see some of that old configuration come back. And finally on Sentinel, yay for flush config. I know people that is, that's a command we've seen out of, seen it recently. Flush config tells Sentinel rewrite your config file. And the reason you might want to be able to do that is maybe you ran an RPM upgrade and it overwrote your Sentinel configuration file. Because RPMs love to do that. Or maybe you ran Puppet and Puppet did that for you. Because it tries to help. Flush config, as long as you haven't restarted Redis, will rewrite the config file and you can actually save that. So, let's go crazy. What kind of crazy things can we put into Redis? Well, time series was already mentioned, so I can't say that one. But we start talking about 12-factor. One of the factors in 12-factor apps is don't store config locally. Put it in a backing store. Backing store meaning whatever you want to call your database. Great example, console, etcd, zookeeper, insert your own here. But basically the idea is rather than store a config file, you query and store it from a server over a simple API. Again, this is one of those when you're running lots of them issues, or maybe you're running a large cluster. Rather than having to go to every node and say, okay, here's your part, here's your part, here's your part, you're this guy, you're this guy. If you have a node ID, or an instance ID for every Redis, and you can query the backing store, you can pre-configure your cluster, bring your Redis instances up, pass in the environment variable, tell them what name they are, they auto-configure themselves. Need to make changes, don't worry about sync, make changes in the config store. And they're already ready. There's some additional things that you can wind up doing with this that are a little bit outside of Redis server side and a little more client side. But once you start thinking about this, you realize, well, if I have my entire Redis configuration accessible over an API, that means my clients can query that. Which means my clients can find out where the slaves live. My clients can figure out, oh, this is a read-only slave, so I'm not going to send any writes to it. And that kind of expands what you can do on the client side. And so that's kind of a crazy idea, but when we think about the whole cloud native thing, and we also can define cloud native a little bit differently. And for me, it's as minimal changes that are persistent as possible. And storing your config in the backing store is one of those. And then let's go a little bit more out on a limb and say, you know what? Don't put the RDB on the hard drive. Store it directly into a cloud storage provider. Right to it. Really not difficult. In fact, I know at least for S3, there is a C library that does it. Don't quote me on what kind of quality it is. It's a little bit old. But from what I've seen, it works. So conceivably, if you combine these two and the metadata and the configuration, now we would have a Redis that you could launch dynamically, self-configures or self-reconfigures, can be fully discovered, and doesn't need local disk. And to me, that gets to where I see Redis in a different light. I've been developing this mindset over the last year. So, of course, I work at Rackspace. We do cloud databases stuff. Redis is one of them. I'm sure most of us think of Redis as in the cloud as a database service. It's data as a service, right? Whether we call it data structure as a service, database as a service, I think we need to go a little bit differently. And instead of it, think of Redis as memory as a service. Because really, that's what it is. We're not doing data structures on disk that we're reading. We're doing it all out of memory. So really what Redis is doing is it's saying, here's a chunk of memory, and I'm going to give it to you. You can access it. And so can you, and you, and you. Memory for everybody. Now, once you start doing that, now I'm going to get into a crazy server-side idea. I even put on slides. It was just great. So we have key values in Redis. We have all sorts of data structures. But they're all data structures. And sometimes, okay, a lot of times, we or others that we see are doing things like, well, serialize this data into JSON and stuff it into Redis. What are we really doing there? We're not really doing a key value. What we're doing is we're doing a Redis API version of grabbing some memory and sticking some data into it. That is completely non-structured for Redis. Redis doesn't know, Redis doesn't care. It just says, I have this section of memory. So let's take a little step further, and instead of saying where you might call malloc, think of a Redis malloc, where you tell Redis, I want this amount of space. Let me put whatever I want to into there. To me, it kind of seems like a relatively simple jump from key value to give me an ID for a section of memory. And if you've ever done any stuff with memory in C, you can probably see the similarities there. So I say, why not take that next step and give that ability? So the client libraries can say, here's some binary data, stick it, associate it with this key. And we don't have to do string conversions, we don't have to do any of that. We just put it directly into memory. So there you have it.
You're talking about being able to use, to be able to maybe jump to the middle of a section of memory in Redis and retrieve a part of it. So we'll talk about the video stream or something like that, as an example.
Yep.
So you can have that implementation already.
Yeah. And you can, I mean, in a way, you do, it's like shared memory. It's just a far simpler, if you've ever looked at, it sounds like some of you have, if you've looked at the shared memory libraries, they are not simple. But Redis is, and Redis is kind of already doing that. So if we just remove that thin layer and give us able, yes, do a data.
Like a pointer.
Yeah.
You just say, I want X, Y, and Z of that.
Mm-hmm.
Okay, basically substrate command.
Yeah.
Mm-hmm.
And that's a use case that we've seen that people want, and you could do that. Or you could just store straight binary data in there. And then when you got that with all this, and you really do have memory as a service. And if you're in the enterprise, you could spin that up for groups within your organization that just, okay, well, you get this much memory. And here's your credentials, and here's your API. On subject credentials, I do want to mention something I've been suggesting is you should always use the auth password in Redis. Not because it's going to help you secure Redis, but because it will help prevent you from doing things like connecting to port 6400 when you meant to connect to port 6401 and doing commands like flush all. I've done it. I've seen other people do it. So if you password protect your Redis instance, not for security purpose, but for oops factor, I really recommend always doing that.
Different passwords.
Yes, different passwords.
Basically, this idea of using Redis like memma, it's something that it's used a lot in the enterprise with systems provided by a company called DeepSeek. Yeah. They are not in the form of Redis like a network library. It's much more like a library you bind in your program. And what they do that's interesting is that you have some local memory that works as a cache in the database and it's versioned. So there is also complete resolution if multiple people try to access in the same memory. And it's for sure an extremely interesting use case because at this point you have your local cache, your shared cache, and there is synchronization primitives. But there is no open source system implementing something like that was enough complete or used or get traction. So the idea is mostly used in financial applications with proprietary systems. But it's a very important idea in many applications, IOPS applications.
Yeah, and if you're dealing with fixed records entries, for example, exchange logs are fixed link records. So you could store that in that fashion and then just access it as if you were accessing it locally. And yeah, Redis doing all that stuff that the libraries that you pay for have to do, to me, it's just, that's code I don't have to write as the guy on the other end of that. And it's stuff I don't have to think about, so it just makes it much easier. And I think that, you know, if we had that, then a lot of log processing can be much easier to do in Redis. You know, if you convert to fixed length, or you do, one of my favorite data compaction techniques is to map everything to an integer. So if you imagine, say, a mail log, you've got sender, receiver, what IP it came from, where it went to, you know, some of those you can just calculate directly in an integer. The others, if you map an ID address to an integer, well, now you've reduced this longer text line into 5 or 6 integers, which stores much more efficiently.
Yeah, for example, an extreme example is counters. If you have like 8 bytes counters and use just the memory address without keys, anything, just one counter, the key is the location of the counter itself. Then the memory efficiency in this setup is extreme. One thing that I wanted to do, you know that we already have, if you have a key with a large string, you can already access some parts. One thing that I wanted to do is provide commands to also increment parts of the string as a counter, binary counter, so that people, at least the counter use case, could be easily implemented in this way. But yes, there is much more structures and stuff like that, and get really tight memory speed.
Your counter example reminds me of something that is on the newer version of this slide deck that came on the airplane. Is something else I would like to see is we have our bit strings, and yes, that's memory efficient if you're talking about a small space there, but once you start talking about large numbers, then that becomes very, very memory intense. You know, if your maximum user ID, for example, your maximum object ID is in the millions or, you know, 2 million range, now you've allocated a large chunk of memory for that. And what I'd love to see would be the ability to do sparse bit strings. If we could find a way to do that, so that I could have, say, a 64-bit ID in there that's not taking the space, the string space of a 64-bit number.
But it's, yeah, if you have a very sparse set bits, and most bits are, or at least if you have many clusters, then one way that works very well to address the problem is to segment the bit array over multiple keys. So many keys don't are ever created at all. However, it's not the same of doing compression, but you lose the ability, of course, of constant time access. Becomes logarithmic at best or something like that. But yeah, it could be.
Yeah, and I did some digging in various C libraries on doing them, and there's many ways to do them. Like, you know what? That's not what I want to do, but I want to have that ability. I'm not ashamed to say that. I can stand up here and say, I don't want to write it, but I would love to have it. That's wonderful.
Do you have any thoughts about how you implement backing stores for configuration without like binding Redis to a constant line?
So, those were bingo Docker again. I think one of the models that Docker went with is Docker actually wrote libkv, which is Go, so it's not directly usable, but it's an abstraction over Zookeeper and etcd and console. In that you set key value, you know, it kind of minimizes to just that main bit. But if we use a library that allows us to do that, then it would just be a matter of giving it, okay, here's where you need to point to. Of course, the console usually is going to be localhost, but you know, if you're doing containers, it's probably not. So ideally, you know, I looked, there aren't any, I mean, it's primarily libcurl based, honestly, is the way, if I was doing it, I'd probably just cheat and use libcurl to build my queries and parse them back. Because the thing about those example key stores is that they're HTTP. So they're very simple. And we would just need a way to basically query and set back and forth over that HTTP API. And ideally, I would see it as a library that talks to, you know, each one the way it wants to be talked to, builds the parameter, builds the JSON object for you. and you just say set this and put it in there.
Well, you could do it with like Unix pipelines or whatever. Like you spawn, you just give Redis an executable and it's talk by actually.
So the main thing is for that is the entry points. So the only real tricky aspect of that to me is getting changes. And that's where each library, each of those backing stores does things a bit differently. For example, console. I like console, I use it a lot, so that's my default example. Console, you can do a watch, you can set, and you can do it over HTTP. You can say, hey, if any of these keys change, let me know, and it tells you the values.
Low right?
Pardon?
Low quality.
Tells on the HTTP API for it. But that idea, I would probably put that in a separate thread so that basically what it does, and conceptually, not necessarily code-wise, basically you've got the thread that's listening for changes on your backing store. When it detects a change, it conceptually says config set to Redis itself. And then Redis does, and that triggers all the existing mechanisms. So if that config set triggered a sync to a slave, that would happen. You know, if that was you could do a rewrite to config and the sync would all be there. And then conversely, if you wanted to go the other way around, and you should, in my opinion, if you do a config set, it should set it within the Redis data structures in memory, and then go talk to the backing store and say, hey, I just changed this variable. And that way they're always
do that today, by the way, probably. Just not a service beside Redis that listens on the changes on command or whatever.
Mm-hmm.
Even using monitor, but there's probably more efficient ways to do that.
Yeah, with console, well, so you can get half of that. You can get, if changes happen, talk to Redis, but you can't get the other way around. And you can't get the querying upon start. So, you know, conceptually you could mimic some of that with console at least, and the delayed start, the delayed availability idea I mentioned earlier, where you start up Redis and then you push in the configs. You could do that with console template actually, and then have that script set whatever the values are that changed. It'd be an ugly template, but it could be done. But with Docker, you can treat Docker like a VM, but you get the most use out of it if you're running one command in your container.
Yeah.
So you're running additional service on the side of it. It's doable, but it's really not the best practice for doing that. Because in that case, if your console template engine dies, then you're not going to get updates in Redis.
Yeah.
And that's where that problem would be. For me, having that in directly in Redis, able to do that would eliminate that entirely.
We're using Docker but not Redis.
My advice on that, if you do want to put Redis in Docker, is to use --net equals host.
That's our
Yes.
Can we ask why?
to
Know why you're doing it for everything but Redis?
Because we consider Redis the state of our architecture. So basically, we want to have, like, if you're looking at Docker as a mutable infrastructure and want to deploy services, the one constant thing that rarely changes is Redis. It's like the foundation that everything stands on. So it's usually if you wanna not just deploy Redis container and it works. Just discuss all the problems with replication. So you hardly do that. When you do that, we're running a medium-sized cluster, I guess. We do that very gently and half manually, but we do deploy containers a dozen times a day. It just doesn't give us the advantages.
Makes sense.
FYI, Docker themselves don't use Docker for
Can I ask you, how do you see the idea of using, if we build something like Redis CP, so a consistent version of Redis, do you see any advantage if Redis would be completely consistent and linearity involved to using Redis directly for configuration management compared to console TCP or stuff like that?
Yes, yes and no. So some of the idea I kind of got, has anybody else here seen CODIS? Okay, so CODIS is a Go implementation of a Redis proxy that does clustering for you on the back end transparently.
But it's AP, not CP.
Right, but the main piece there is they store the configuration in the backend store. The cluster, rather than being configured directly, is actually stored in the config, and then there's a separate component which is a proxy that you actually talk to, and it, when you say, hey, I have a key, it goes to the backend store and figures out where that key is there. So if we take that idea, then it is possible you could actually do some of your Raft implementation through the backend store, depending on the backend store's capability. Now for console, you actually could. It has leadership election built into it. And so it does have a primitive, so you could do that without writing code inside of Redis, if you so chose. So I say it could. You know, it just depends on where you want to store that information.
Yeah, I mean, if we building a Redis CP from the point of view of the user, it's completely transparent that the data is materializing in Redis. The Redis instances can completely restart and be empty, but there is the draft log in the Redis CP that populates again. So basically it would be exactly like console or a TCD from the point of view of the guarantees, but you have the Redis data structures. So it will be very similar from this point of view.
Yeah.
So the point is to understand if it is really or not an improvement for the kind of workload console and TCD are used to have data structures or not.
Yeah, I don't think, I actually did think for a little bit last week about the idea of putting AOF into a backing store. But when you look at most backing stores, if I were to choose a backing store to put AOF in, it'd be another Redis instance, because they're not designed to handle high writes. They're a low write, high read.
Yeah. So
I don't think I would put that log in there. Other aspects that you need to make those decisions in there. And whoever's up next, everybody over there, don't feel bad when we're squinting when you look over there because those lights are really bright.
Yeah, Bill, one question. Is Sentinel really be ever useful? Like, we have in one set of masters to have like a synchronous delete and synchronous setting, because we have an issue for us, and also be very quick on each other and doing failovers and stuff. So will that ever be useful?
So, make sure I got this right. So, are you asking if it would be useful if you could talk to one of your sentinels and say, delete this from everybody? And do that synchronously?
And I get some kind of confirmation back that this has actually happened. Because, yeah.
So there's two aspects, two ways of that. One is what I just said, which is go delete this from the entire sentinel. And the other is don't tell me you've deleted it until you've actually deleted it, right?
Yeah.
Yeah, so it's definitely there. And then that kind of goes back a little bit to the issue I mentioned earlier, that if you delete it and then you re-add it, is that when you delete, when you say sentinel remove, it goes okay. It either goes okay or I don't have that guy. Those are the only two possibilities. And it doesn't actually get rid of things in between there. It's basically an asynchronous call in that sense. And so in those cases, it's definitely an issue. So being able to say, I don't know, maybe throw sync on the end of the remove call or something like that, and say, don't make this a blocking call, would be one option, and sync would be another way to push that out to all of them.
The problem that Bill mentioned, it's not that there is a race condition so that things are not really removed. It's removed, but maybe send a message to another sentinel about this specific master name. The message is no longer in the materialized as a master in the memory of sentinel, but it's serialized in the output buffers in the socket. So when we react back the new master with the same name, this message still is there. When the message reaches the instance, having metadata and epoch an epoch ID, configuration number, everything that was felt the materialization of the same master with another name. It is sensed as to be the new thing. So, oh, my configuration. So basically, what should happen is that when you remove a given master, you have no way to scan the output buffer in order to remove the comments, but you can flush completely the output buffers. I mean, completely of Sentinel between Sentinel, and this should remove the issue. Basically, because of how Sentinel works, it's always safe to flush the output buffers even if there are pending messages, because messages will be sent again and again and again. So the simple fix will be, because you have no race condition, but you have pending messages that are ambiguous from the point of view of having the master name. Otherwise, another thing that could work, but it's not maybe great design, but actually could fix the problem, is that Sentinel would remember the name of masters that were recently removed and don't allow you to re-add them, if not after, I don't know, 30 seconds or stuff like that. But it's not very elegant. No, I don't want, but 30 seconds, yes.
But I do like the idea of being able to say, talk to one Sentinel and say, delete this from every Sentinel that knows about it. That goes back to what I was talking about earlier about not having to go to everybody. It should actually be a good way of helping solve some of that.
That's very useful from the point of view of the administration. The reason I never end doing it, but I will do it one way or the other, is if there are network partitions, some Sentinel is not informed. So my fear is that it provides a false sense of a consistency that's not there. So I say, Sentinel, please remove this master, and also make sure all the other masters will remove it. If we do this, we must make sure that the Sentinel is able, like for example, this queue does in certain links, that's another project of mine, to make sure that everybody is informed, otherwise the information is retained in memory. And only when every Sentinel, then I see, okay, now I have peace of mind, I can remove my information. Otherwise, it must retry forever until the message is really delivered to everybody. Something like that. I don't know. It's useful because if you have a large deployment, it's great to a simple route that's, you say, synchronously removal operation across all the cluster, and say me that it succeeded only if all the instances reply. So give an error if we cannot complete the operation in a consistent way immediately.
Yeah, and that reminds me, there's actually another Sentinel thing I'd like to have, and that's right now. If you connect, say you have your three Sentinels, and you get a network part of your minority. And let's say that the minority is the master, so the classic split brain, right? These guys promote a new master, thinks he's the master, and that Sentinel still thinks he's the master because he doesn't know. And maybe this is something with the connection rework you could do. If the minority Sentinel can detect that he's in a minority, then he should say, I am not going to answer any queries about who is what. So if the client, so in that situation, if the client then connects to him and says, give me the master, right now he was wrong. But if Sentinel was detecting that he's in the minority, then he would say, you know what, I'm going to take the safe route, and I'm not going to give you the master.
The reason I didn't implement this is how Redis cluster works, basically. The minority partition becomes unavailable. It's because in the case of Sentinel, if the partition doesn't heal, the new configuration cannot win. So Sentinel reports that the master is still the old master. But you can configure the master itself to detect to be in a minority partition and becomes viable. So the advice in the Sentinel configuration is when one wants this kind of guarantee to configure so that when it's isolated in the minority partition, it stops receiving writes. So Sentinel will say, yeah, this is still the master. It's no longer true because maybe it was promoted, but the master will decline. There is a solution basically.
What I saw is if you search for HA proxy in Redis, then you'll find people, there is an HA proxy health check that will query, say, are you the master? And if so, it will allow it in. The idea there is that you can then only talk to the master, but the reality is if you get in split brain, then you are perpetuating split brain, whereas if that proxy, instead the solution is you have to query all of them. You say, okay, if I get a majority of sentinels telling me that this guy is the master, I'll go ahead and connect to him. I got the idea of, well, if Sentinel didn't give a master, then that check would be much, much simpler, and you wouldn't have to do that.
When the partition heals, HA proxy will ask again in order to make sure that the information is eventually consistent. Yeah.
Yeah, because when it heals,
the partition.
yeah, because when it heals, the Sentinel should again start seeing the connection, and the messages. The other Sentinel realize it's back in there. Then I think if its configuration epoch, it would know that hey, somebody else got promoted, and then it could do its normal failover thing. So it can detect that condition coming. It can detect that healing.
As it is currently, maybe HA proxy doesn't follow the Redis specification.
Oh, no, it absolutely doesn't. It doesn't know.
Just ask.
Yeah, it's a TCP check where it's like expect that, send this, expect that, send this, expect that. The idea of teaching HA proxy to understand Redis is a whole different ball of wax, big hairy ball of wax. But it's that particular case, and then it's also useful, like say for, even if you're not running HA to connect to that minority master, during the network partition, they're still going to get that master. And so that in particular is the problem I'm looking to solve there. Because if you can do that, then you can, I can't say this categorically, but I'm going to say it generally, I imagine you could actually eliminate split brain as a problem at that point. Because if the master will already master and a Sentinel won't tell you the master because he's in the minority, then nobody will be talking to that except people who are still, except connections that are still open. And maybe that's something that should happen. Maybe when that master detects that he's in the minority, he disconnects all the clients.
But this is already like that.
Okay.
But it's an optional configuration. No, it's not mandatory. So in the basic configuration, the old master remains accessible. It's not in Redis cluster. The default is that the minority partition becomes not available. With Sentinel, the default is that the master still is reachable, and you have to configure in an explicit way this thing. As long as the master senses that it doesn't receive the acknowledges from the majority of the slaves, it detects to be in the minority partition and no longer accept only the writes. The reads remain accessible. So probably it's also sometimes useful to. But when the partition heals, the clients that are connected to the old master for error are terminated. So if the client follows the right protocol, they will try again to ask Sentinel and destroy the conversion.
So when the partition heals, it disconnects. But does it disconnect when it detects that the partition is happening?
When it detects the partition up, it starts to refuse the write commands.
Okay.
Just that. Because it's no longer in the majority. So basically, the other clients will still be able to read the still information, and this can be easily provided as an option to also prevent reads because it's useful in certain stuffs.
It almost feels like it'd be useful to have some sort of proxy to Sentinels too. because some entry proxy configs also contain different sentinels to find out what's the master. So a lot of like log setting and resetting of configs is done by picking individual sentinels. So a lot of places we're picking different sentinels to set, to change. And so a lot of this intelligence you have to build in these various places. So like in my client, or in one of the sentinels I talked to, we have some sort of this proxy intelligence, different proxies to use it.
Basically, there is one proxy that is pretty much a good start from the point of view of the Redis proxy, but it's a shame that it has no Sentinel support and Redis cluster support, because this allows you with all the clients to use Redis cluster and Redis Sentinel much easily. But the creator of Twin Proxy wrote it while it was a Twitter. And then he is extremely open to accept patches and work with you and so on, but he's doing his startups and stuff, so doesn't have the time to undertake this big amount of work. So probably at some point in the future, we should say something like that. Let's take Twin Proxy and make it part of the official Redis ecosystem and actively develop it, assign to it a developer paid by somebody, I don't know. But let's say it a first class citizen of the Redis ecosystem. Would limit a lot of problems. Yeah, it's the Redis, the Sentinel client shake protocol is one page long. It's not very hard, but still, even the Ruby Redis client for the Ruby language, that's probably the most used or something that had a correct implementation only when I had enough and implemented it myself and sent it. Because otherwise, it was impossible to get support for this simple feature. Probably it's because most pages to the client ecosystem came from individuals using Redis in small projects, and instead the most focus of Sentinel Redis cluster is in the enterprise that contributes 0. So a split brain condition.
And there was discussion on 2M Proxy's list this summer about adding Sentinel support. And it came down to the individuals looking to implement it were really just looking to implement proxy and Sentinel commands themselves. Whereas I would imagine that if we were to bring it in as a first-class citizen, we would instead want it to speak Sentinel so that the clients don't have to speak Sentinel.
Exactly.
Because that, I mean, that was a big problem. There was quite the discussion on it about like, no, if you are the proxy, you are acting as the client to Sentinel. You have to do it the Sentinel way.
Absolutely.
So if we did, then yeah, we would go.
Even to go even the extra mile and say, I want to scale for this kind of request, I don't want read after write consistency, so automatically split the requests among the read slaves. I don't care. I just talk with you. You do all the logic. The slots logic of Redis cluster, the Sentinel queries, everything. You just become an infallible, an impossible to get down point of view. And I speak the same protocol I used to speak that I really trust anything. It's all about you.
Yeah. And if you're storing your config backing in a key value store, then 2M Proxy can talk directly to that. You wouldn't have to configure 2M Proxy with, we'll use this node and this node and that node. You just say, here, go talk to this guy and pull it all out of the configuration.
And one incredible thing, that you get with this setup is a lot more performance. It's true that there is a hot model, but 2M Proxy automatically implements pipelining of requests coming from multiple clients. So it glues together the same request, sends as a unique read from the point of view of the master, and it's a very simple way to use pipelining in environments where pipelining you cannot use it in the single connection, because you use the reply for the next request.
Yeah. Yeah, Codis is really fast too. So in many cases, it's actually faster Intune proxy, which was really surprising to me.
Great.
But yeah, that basic idea of having a Redis proxy that implements the really performance critical pieces of understanding the parser, knowing topology, knowing that type of stuff. If we had a Redis proxy that had all that in it, then you could do things like add SSL into your proxy. Just take that, add SSL into it, and we don't have to put SSL into Redis necessarily. You could just do it that way. You can do all sorts of things with that type of a model.
Absolutely.
Just because I know people's stomachs are probably like screaming at them right now. I know model is supposed to go next to talk, so should we have one more talk and then lunch, or should we break for lunch now and then come back?
Let's do one more talk.
Yeah, we can continue the talks in the second part, or we can do the talks now and later go to lunch. It's up to you.
Maybe one more talk and then go to lunch.
Makes sense. Like more 50 minutes, something like that. So
should we have one more talk and then break at 1?
Yeah.
Then you guys can head out, grab everyone and come back.
makes sense.
Okay.
Thanks.
Do a quick one.
She's still looking at it.
Yes.
Just make sure you can see us, okay?
Very interesting. Yeah, it's always. Yeah, sure. Okay. Yeah. This is going to be. Oh, yeah. That's very important. Let's see if we do it. Yeah, he's like, even know as much as you like. Do you ski? Yeah, do you really? Yeah. Yes, finally, yeah. Quite about the sea. Yeah.
So guys, I don't want to speak about Sentinel cluster, that's too complex for me. And there's something easier. It's about microservices using Lua.
Can you give a short background about yourself?
Infrastructure consultant, so I work for different company. But in my spare time, it's 3 years I'm spending time to do monitoring system, where the whole code is in Redis and Lua. Looks a bit boring, but because it's the fun bit is using Redis. I know. So first of all, we want to use Redis because it's fast, but you still have to move data in. So why don't we do the majority of processing inside Redis? So we're using Lua. In such a way, you can be fast, but you will reduce the network traffic, so you can even go faster. That's the idea. So using Lua, this is the stupidest example you can think about. Right? I'm using JSON, or I can use message back that is more efficient. And I can say, just load this script, and I can just say, provide as an argument an array, and I'm getting the highest score, right? This is just a stupid way to implement a kind of intelligence with Redis. Very basic, but it's the starting point. So the idea of reducing bandwidth is useful. For example, you have a key as a method set where you can get all the key, and after you can do some metadata generation. So you send out of Redis only what you need. In this case, it's just the header of my string that is my time series at the end. So in such a way, I'm not fetching all the key and doing the processing of my application. I'm just calling the script that gives me the header of all my instruments. If I have lots of keys, this one will be much faster than fetching all the data on the server side and do different loops. All the code are inside Redis, and there's no faster way to generate this data than asking a Lua script to do for me.
And how do you debug it?
So Itamar just suggested to use there was a blog post about using a pub subsystem, right? So every time you run something, you can do publish in a queue. I'm not saying to write 1 million of code in Lua. Lua must be simple, must do simple jobs. But this stuff there's not big logic inside, right? It's just pretty automated interaction, stuff you have to do quickly, and it will always be that one. So in such a way, you generate data, and it's not so complex. I know it's not the fully fledged. At the beginning, I remember that I wrote using Redis as application server, but was shooting too high. So I said, okay, let's say just microservice. That is something easier to implement. Now, let's move to a more advanced example. So I wanted to do a lookup service for the network between IP and autonomous system. Autonomous system is basically the label for a network that is over. I manage this class of public IP. Now, looking up IPv4, you need, in theory, there are 4 billion IPs. Okay, less than some clusters served, but still, the data is pretty big. And you want to generate this way in a compact way, because these information change not so often, but they change even daily for some small networks. And because we have to distribute this data on different nodes, this data must be compact. The lucky advantage is that these information are already defined, are already structured, because it is an IP and there's a number. And the logical way was to use a set. What I was thinking is what I used at the end is using as a key the autonomous system and using the IP as a score. So I make it out of an IP, I make an integer, and I'm using that. I could have done other way of looking up. I could have used lexicography, but I wasn't sure if it was faster, so I said, I don't know. The new index will be cool when it will be there, but for now, that's my idea. Next slide, there's pseudocode. It's not the real code, it's pseudocode. But first of all, that's just an example, right? So the network 1000 is autonomous system, 1004 by this system. They are not contiguous, there's information around the internet. I want to look for this device, for this IP. So I'm creating my set, and I can do that arrange by score, and I will use the IP and another value that is lower. So to find where is the IP in the big list of scores. I'm using this strategy because I checked my data structure. So the whole autonomous system listing, there's half a million of entries, and the majority are more than half are small network. So I will split my search into half, starting with small network and going with upper networks. So that's the code. So that's ugly, but I couldn't do much better for now. So I need to split the IP and making an integer. That's a bit ugly, but it works. And anyway, I will start looking for the data. I will start doing data by score, the IP -4, -8. So this is to find, because an IP there's always the zero usually, so the first one of the network. So I will go down, few back. If I found a score with more than 1, I can get out of the loop because I found the network that contains data. I could find more than 1, but I will, that's the other way around. When I'm saying if I didn't find anything with smaller network, I will go on the bigger networks. So this logic I just load, and I can just do eval SHA, the IP, and it will return me the autonomous system. Here, because the different autonomous systems, they're not contiguous, and they can have more networks. So in such a way, I managed to not having any clash, basically. So for the performance, so basically, Salvatore used TLC code to do some stats out, to test some stats, and I thought, actually, I don't want to use a test. I don't want to use an external program to do something that I want to measure inside, but I need a random number. So I came out with this idea. Basically, I'm combining random member and using random member in the match random as a seed. It works. I don't know if it's truly random, but for what I need, the generating IP works fine. And I didn't test on cluster, so yeah, it works on cluster. But for me, it's just looking up a big data set that luckily is structured enough to be queried in the fastest way, faster way. So start running. So here is few tests, right? I'm not providing an IP because the IP gets randomized. So that IP converted in IP, converted in integer, and that's the autonomous system. I will, because they are scored, they are sorted, I will also create the last one. And in this case, there are multiple ones, so I will always get this one because I'm looking for a bigger network, and this network is over. My IP is overlapping lots of networks, so I will get the last one. And I can verify in the raw data in the script. So how fast is all this craziness? Actually, it is very, from my understanding, it's very fast. So if you have a look, the worst case scenario is 26 milliseconds. So the word key is 80 meg, so it's not huge. But I mean, for doing this logic on any other way, it would be much complex, much slower than doing all this chunk of work in Redis. Later on, in the future, we may have clever way to do this sorting, but as a Lua script works pretty well for me.
What you can do is to directly add the IP you are looking for inside the sorting set. Okay. Get the rank of the element.
Yes.
And then you know that the element immediately before was your network. So you can avoid a lot of computation.
I get the rank, okay.
And then you can ask by index what the rank you obtained -1 is the network. And then you remove the temporary element you have. So in just 3 operations, you can look up directly the network.
Okay, I need to check if the networks are not all continuous. Sometimes there are holes because they are not announced.
Yeah, if you get the network redundant will be clearly out of range.
Okay.
And you know there is no match. But maybe you can speed up this because you can still send it using a network script. And also with the lexicographical range, there are other ways. But the fastest, I believe, is to try to insert the address, the full address, and get the position, and then check the previous position.
But I didn't generate your IP here. I have just a net.
But when you want to try to insert the IP you are looking for, it's like if you have an autonomous system composed of just a single IP.
Yes.
Okay. And so if it is contained, if it is announced, if one that contains it is announced, must be before it.
Yes.
And so you just access by indexing the one before it, and if there is a match because it's really in range or out of range. And could speed up this process maybe.
Yes. I mean, output.
Now.
Okay. Anyway, I didn't want to bother you about this particular example, but just to show you that in my way you can do complex stuff, if you define complex, with a script inside Redis, and it will be the fastest way to get this lookup. That is kind of intelligent lookup because you need to do some research. And so what did I learn about the world system I'm building? That first of all, in monitor, I would be nice because you have lots of Unix socket IP and you have Lua. Would be nice if you can know which script. I have multiple scripts running. Which script, so which function is doing here, right? You can, because I mean, Redis actually know what is running, so you should just put here what is running, right? Because everything is asynchronous. There are a million of connections, so you want to know what's going on. It's not just Lua. Lua is a bit too generic. If you want to use the other bit that I would really love would be an alias. So every time you have a SHA, but because it's not just used by the masters, by the Redis, even by the client, you need to keep this SHA updated between all clients. So I have kind of init function that say, hey, that's the list. If you want to call generate metadata, call this SHA. If you want to call this one, generate this one. So why don't we can have like script load, script alias something. So in such a way, every time you reload the same alias, you will override the code. So you can forget, basically it's an abstraction layer between the SHA itself, that is just the base, the SHA of the code, but it's something more useful.
When the Redis client is already doing for you. When the Redis client item is already doing for you, just give him the script, you get some kind of handle, and you just send it to run script.
You can, but the advantage when the Redis script does it for you is that you are sure that the alias will correspond to the version of the script you have in the program memory. If we do script, this feature was avoided on purpose.
Okay.
Because it introduces the problem of versioning things with the same name.
Yeah, I see. But it's okay to synchronize everybody if everybody's calling a different function.
No, actually, you don't have to synchronize it because of this feature is missing. Because you have the copy of the script.
Yes.
Oh, you don't want to have the copy of the script in the client?
Usually not. No.
Oh, okay.
But anyway, I'm not trying to sell you. That's what I would really like to ask.
Yeah. It's important to understand the motivations in here. So in this case, you don't want to have the copy on the client and call this directory as a remote procedure call that's completely opaque to the client.
Yes.
Okay.
Yes. And the last bit would be something to keep this mapping. You could even have a kind of ladder, right? So in a Lua script, you can call some other function in such a way. Or doing an include something. Lua, I know it doesn't have to be million of lines. But trust me, with already 200 lines, because you can read the bug properly, because it's a bit of a pain to bug you, it's lots of guesswork. Would be nice if you can include, instead of having a huge inline with all different functions and the script on the bottom.
Once you have that, you can do the same or bit. On top of that, like a repository of installable Lua, if you have that.
I'm working on the low level, right? So I'm just speaking with Redis and I'm not having much layer on top of me. But yes, if the client does already that stuff, cool, but I have my simple 10-line PHP client that does the protocol. So it's different. If you wanna, I don't like having whole stack of software in front of me. Just have the one I know to use to pretend to know, and that's all. But in the past about being possible to include something to call something that. Again, we can put some limit, I know, but it would be nice to be more manageable. Any others using Go in such a way, or only the crazy one? I'm the only crazy one, okay? That's fine.
Is it possible to lock certain keys from within I would think not speed, but consistency. Like if you use it like a small procedure, so basically you go in there and you perform some action that requires multiple keys, but you want them to stay consistent while you're finishing the function.
Lua is atomic, so when it runs, it does the same. It is running.
Okay, so you just single thread.
Yes.
So you can use that way. Otherwise, for multiple clients, you can't like keep stuck.
Yeah, you look at it. You need to be careful.
I just want to say that that is actually one of the best. Here's a good use case for Lua that I've seen, the IP address and the network range. A lot of examples I see really are things you can really simply do that you're really not buying anything. So kudos for using network as your example there. But I do wonder, what about a native IPv4, IPv6 data type from this?
IPv6 with ranges, with lexicographic ranges.
Because then, I mean, there's a ton of libraries that do that, that basically give you a data structure that is an IP address or a CIDR address. And then you can do that math, and then, if we had basically in Redis, and you have those various commands, we can say using network and do that in Redis itself, which may actually, I would imagine, would be more memory efficient for one.
Yes, definitely.
Because then you're just doing image stuff. It would probably be even faster in that particular case.
Because anyway, everybody's reading logs and correlating IP, and if you want to go in security stuff to keep in memory to do anomaly detection, so maybe for me it makes sense to get something. At the end, is a bit mask. IP, bit network, net mask is a bit operation, and you're good with operation. Well, that's all.
I have the purple because it's actually possible right now to call other Lua scripts because it's side effect of the implementation. So you can call actually loaded Lua scripts by using f_initial just as a function in Lua script. So this at least gets you kind of handy way to do this what you want. You don't get nice names, but at least you can call on scripts.
Okay, that's fine.
So it's about 1 o'clock right now. We have this space until 4. So if you come out of the building and turn right, and then turn right on Wilson Street, there's a plethora of places you can grab a sandwich, salads, there's certain places, prep, eat, pod, a bunch of places. I recommend we get back here and get started again by like 1:40, 1:45, so we have time for everyone else to speak.
Yeah.
If you guys can just bring your mugs back to the kitchen and you took one, that would be great.
Still not getting into it. Do I have to season in your what? Okay.
Yes, it's not right. Nice one, anyway.
Yeah, they got